Hello, this is Jan from Simple Tree Project, and I want to talk a little bit more about the other output files. So we have one file. Um, I This is my improved model. We have one file which is named with stats. That is this file. So we have here the name of our cloud. And here's the total volume. This is quite easy to interpret. It should be the same number as here. The dBH is also plotted already in this visualization as well as the height. And so the solid volume, let's go through this file and not through the visualization. So we have the total summed up volume, the volume of all cylinders with a diameter larger 7 centimeters. So the rest is considered twigs or not merchantable wood. So like 1/3 of the tree is below 7 centimeter diameter. That we can say already from these two numbers. It's a small tree, so we don't have so much. The volume of the stem. So I can make my tree model transparent, and this is automatic detected stem. It looks quite nice. Here is the colored cylinder. This is along dBH height. So this cylinder radius is taken for the dBH computation. But yeah, this is the automatic detected stem. And if we go back to the file, we have height, which is if this coordinate, the Z coordinate. So it's just the height above ground from the top cylinder. And we have a second measurement. This is a little bit larger, like yeah, 8 centimeters. It's not the height above ground. It's the length, the path along all these cylinders here. So the sum of all the lengths of the stem cylinders. Okay, so that's a different. And as we have here a little bit curvature, the length is a little bit more like 8 centimeters than the height. So I showed you the colored cylinder. Its radius multiplied by 2 leads to dBH. The root diameter is just the diameter of this lowest cylinder here. And the root height is the height above ground, where I did cut the point cloud. Then we have the volume until the first branch, 60 liters only. So 1/3 of the volume of the tree is, I need to make my tree visible. So I think this is already the first detected branch in this case. I forgot how I implemented, but yeah. If you will really use it for a publication, I will look, or I can adjust this. So you could also look for the first branch with a volume larger, let's say 2 or 3 liters. Then it might be only this branch and not these little shoots here. But now the volume from here to here is like 60 liters, which we have here. Then we have the volume until the crown, and so the crown starts, that's where the crown starts, yeah. So I look for a branch with a volume larger, 2 liters or something. It's a hard-coded threshold. Uh, so the volume until the crown is the volume from here, from down here till here. Then we have the height of this branch. where the crown starts. So this is 4.7 meters. And we have the volume area and crown projection area. So the volume is the volume contained in this green struct. The surface, the second parameter, is the surface of this hull, and the crown projection area is if I would press this green blob to the ground in 2 dimensions. It's a classical crown projection area. So, and there is a second. So this is all the parameters. And we had here a second crown model, this one. This is not plotted in numbers. If you want to use this for photosynthesis analysis, you have to contact me and I can plot this out. It seems nobody is interested in this kind of model until now. It's there, but it's just not in the files. So this is all is decent crown. As I will show you now. I stop now. In the next tutorial I will briefly talk about these buttons.